All right, today we're going to be learning about solving linear quadratic systems by graphing. We're spending 3 days on this one section, this 9-7 section. We're going to spend 1 day on solving the systems by graphing. We'll spend another day on solving them by substitution, and then we'll spend another day on solving them by elimination. I'll break it down to 3 days so it's not too much information at once. Now, I'm sorry, I have to film this lesson specifically on paper today since we're doing so much graphing. It would be a mess on the whiteboard because I would have to draw a zillion coordinate planes since I can't project. So if you do not have a printer and you cannot print these guided notes, you have to do this lesson on graph paper. If you don't do it on graph paper, you're going to have a hard time being accurate with this. So that is my suggestion to you. Okay. We learned in the beginning of the year about systems of equations, and we learned how systems of equations, when you're finding the solutions, you're finding where that system intersects. So in the beginning of the year, we worked with just like two lines, and we found out where those lines intersect. We are working on linear quadratic systems today, so we're finding out where does a line and a parabola intersect. That's why all of these are, this is a line, right? This is linear because the exponent's 1, linear, linear. This is your parabola because it has the x squared in it. We're finding out where these two functions intersect. So, no solution. This parabola and this line, it's no solution because there's no intersection point. They don't intersect each other. This one is one solution because it intersects at one point right here, okay? It's a tangent point, okay? And then two solutions, this one intersects at 2 points. So hopefully that makes sense to you. Okay. Try it. How many solutions does the system of equations have? Okay, we're going to start off with graphing the line. Now, when you graph these, you have to graph a lot of points, more points than you normally would. So, y equals x, that's a line with a slope of 1. Okay, that is a line with a slope of 1. So, and then the y-intercept is 0, right? So we're starting at 0, we're going up 1 over 1, up 1 over 1, up 1 over 1. Okay, keep going, and I want you to plot a lot of points for this, basically as many as you can, because we don't know where it's going to intersect, so we need to make sure we're super accurate. Connect the dots. There we go. Okay, next. Parabola. This is the parent function for a parabola. The pattern for graphing a parabola, we've gone over that. It is up 1 over 1 in both directions, right? Then up 3 over 1, up 5 over 1, up 7 over 1. Now, sometimes in class, we've really just been going to the up 3 over 1, because then it'll go off the graph. For this, you're really kind of have to go up to up 7 over 1, sometimes, depending if you don't see the intersecting point right away. Okay, so starting at 0, 0, up 1 over 1, up 1, 2, 3 over 1, up 1, 2, 3, 4, 5 over 1. I'm going to stop, and I'm going to do the other side. Up 1 over 1, up 1, 2, 3 over 1, up 1, 2, 3, 4, 5 over 1. By the way, please make sure you're watching this video in full screen, because it might get chopped off if you're not. And then also make sure you're watching in highest quality. You can change the quality on your YouTube video. If you have trouble with that, let me know. There's like 3 little dots, and then you click on the 3 little dots, and then there's like a quality thing, and then you change it to the highest quality. But if you have trouble with that, let me know. Okay, so we have 2 intersecting points here. This is an intersecting point, and this is an intersecting point. So we have 2 solutions, that means, since it intersects at 2 places. And the solutions are 0, 0, and 1, 1. Okay, next. This looks a little different. It's actually still 2 lines. Okay, so I wrote first step, set each side of the equation equal to y. Okay, so we're going to set this side of the equation equal to y, and we're going to set this side of the equation equal to y. So we have 2 parabolas. So we have y equals 5 minus x squared. Okay, setting that side. Then we have y equals x plus 3. I'm going to rearrange this a little bit so it's like, I don't know, looks better. Y equals negative x squared plus 5. Standard form, right? You list the exponent first. So these are our 2 equations right now. Let's start with the line. Graph the linear function. This is a line with a slope of 1 and a y-intercept of 3, so we're going to go up to 3, 1, 2, 3. Slope of 1, so we go up 1 over 1, up 1 over 1, up 1 over 1, continue, opposite direction. Try to be as accurate as you possibly can. If you can print these guided notes, it's going to help you a lot. If you can't, graph paper is your friend today. All right, next, parabola. Negative x squared, that tells me it's a downwards parabola. So instead of going up 1 over 1, I'm going to go down 1 over 1. And it's moved up at 5. So we're starting up at 5. This should be review, right? We remember how to graph parabolas, I hope. Down 1 over 1, down 1, 2, 3 over 1, down 1, 2, 3, 4, 5 over 1. That's really all I have to do because I can see where this is going to intersect right now. This is an intersecting point, right? Because we went down 1 over 1. There it is. But I have to do the opposite direction because I know it's going to intersect somewhere over here as well. Down 1 over 1, down 1, 2, 3 over 1. There we go. That's our intersecting point. You can go again, 1, 2, 3, 4, 5 over 1. Okay, so we have 2 intersecting points. I'm kind of putting like an extra circle around them so it's very clear. You don't have to. It's up to you. The intersecting points are 1, 4, and negative 2, 1. So 2 solutions. Okay, next. Let me actually fold this paper this way so then it brings it up higher on the screen. Like that. That's better. Yeah, okay. Now, let's start with the line. This has a y-intercept of negative 2, so we're going to go down to 2. A slope of 4, so that's up 4 over 1, right? Up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. Down 1, 2, 3, 4 over 1. Oops. No, that's right. Okay. I don't know why it looks weird to me. Okay, there we go. Now, let's graph the parabola. This parabola, this is in vertex form, so it has a vertex of negative 2, negative 6. Remember, opposite of what's inside the bracket, not the bracket, the parentheses, since the formula is y equals a times x minus h squared plus k, okay? Do the opposite of what's in here. So negative 2, negative 6 are vertex. So let's plot that. Negative 2, negative 6, that's right here. Then we're going to follow our pattern. A is 1, so it's still going to follow that up 1 over 1, up 1, 2, 3 over 1. Oh, here's an intersecting point. Up 1, 2, 3, 4, 5 over 1. And we'll do the opposite direction. Up 1 over 1, up 1, 2, 3 over 1, up 1, 2, 3, 4, 5 over 1. Okay, so this has one solution. They're so close together, it looks like it has more, but it's really just that one point. So that would be 0, negative 2, one solution. And you can write that here as well, 0, negative 2. Okay. Next. Okay, y equals negative 5. When it's y equals something, that is a horizontal line at negative 5, so it's right there. Horizontal line. This parabola is in standard form. So standard form, we have to do x equals negative b over 2a to find our vertex. We remember that? X equals negative b over 2a. A is 1, b is negative 2, c is negative 3. Okay, so x equals negative b, so it's positive 2, over 2 times 1. So x equals 2 over 2, and 2 over 2 is 1. We plug back in to find our y value. Y equals 1 squared, plugging back into this equation, minus 2 times 1, minus 3. Y equals 1 minus 2 minus 3. Y equals 1 minus 2 is negative 1 minus 3. Y equals negative 4. Honestly, you don't have to write down every single little step here. I'm just, laying it out there for you. Okay, so our vertex, we plugged in 1, we got out negative 4. 1, negative 4, so let's plot that. 1, negative 1, 2, 3, 4. And A is 1, so the pattern is the same as it always is. Up 1 over 1, up 1, 2, 3 over 1. I'm not even going to continue with any more than that because I know that's not going to intersect. 1, 2, 3 over 1, that's fine. You can see that it doesn't intersect that line. So that means that there is no solution because there's no intersecting points. Last but not least, example 5. Okay. For this, let's start with graphing our line. Up at 2, then it's down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Make sure you're graphing as many points as you can so it stays really accurate. Okay, parabola, standard form, so we have to do x equals negative b over 2a. X equals, b is 2, so negative b is negative 2 over 2 times negative 1. So x equals negative 2 over negative 2 is positive 1. Now we need to plug back in. Y equals negative 1 squared plus 2 times 1 plus 7. This confuses kids sometimes. They think like, oh, negative 1 squared is 1. No, it's 1 squared, because that's what you're putting in parentheses, is the 1. And then the negative stays in the front. Okay, so it's still negative 1 plus 2 plus 7. Negative 1 plus 2 is 1 plus 7 is 8. So our vertex is 1, 8. Plugged in 1, got out 8. So we're going to plot that 1, 8. Now this is a downwards parabola because we have a negative in the front, okay, negative a. So we're going to go down 1 over 1, down 1, 2, 3 over 1, down 1, 2, 3, 4, 5 over 1, down 1, 2, 3, 4, 5, 6, 7 over 1. See, this is why you have to graph a lot of points, because we do have an intersecting point over here. Okay, let's do the other side. Down 1 over 1, down 1, 2, 3 over 1, down 1, 2, that's the intersecting point right there. Yep. Down 1, 2, 3, 4, 5 over 1, down 1, 2, 3, 4, 5, 6, 7 over 1. Okay, so the two intersecting points are, this one is negative 1, 4, and 5, negative 8. So those are your two solutions. Okay, that is it. You have 4 problems to do today. It's a worksheet. It looks very similar to this. I have a step-by-step how to do over here. Make sure you refer to those steps. And have a great day.